A partner of ours gave their OpenClaw agent a vague command. It was connected to a database with over 40,000 entries, and the agent decided the best way to handle that request was to deeply analyze every component of that database. Their manager started getting Anthropic billing alerts while they were driving. $50, then another $50, and then another $50. And he had to pull over to the side of the highway, log into Anthropic, and then kill the API key. So that's a real story, and it's not even the worst one. Um, so before we get into these horror stories, you need to understand why this keeps happening. OpenClaw is agentic, and that means when you give it a task, it doesn't just answer, it reasons, it plans, it calls tools, it executes code, it reads results, it reasons again, calls more tools. So a single prompt can turn it to dozens or hundreds of API calls behind the scenes. And here's the thing that most people miss. There's no built-in spending cap, right? There's no circuit breaker at OpenClaw. It uses a direct Anthropic OpenAI key, right? And the agent will keep going until the task is done and the context window fills up or your credit card just says no. So story two. Now, this one made international news. Summer Yu, the Meta's director of AI safety and alignment, gave OpenClaw access to her real email inbox. She told it to suggest which emails to archive or delete and explicitly said, "Don't take action until I approve." So this worked great on her test inbox. And then she pointed it over at her real inbox. Thousands of emails, and then the context window filled up. OpenClaw ran compaction, where it summarizes older conversation history to make room. And during that compaction, it lost her safety instruction entirely. The "don't act before I approve" constraint, it was totally gone, summarized away. The agent defaulted to what it thought its job was, which simply was to clean the inbox. So it started bulk deleting hundreds of emails across multiple accounts. So she tried to stop it from her phone. She tried, "Do not do that. Stop OpenClaw," right? In all caps, nothing worked. The agent was mid operation and it had no real time interrupt channel for mobile. So she had to physically sprint to her Mac Mini and kill the process manually. Meta's own alignment director, the person whose literal job is preventing AI misalignment, couldn't stop her own agent. So the lesson here: context compaction will eat your safety rails. If your critical constraint is stated early in a long session, it can get summarized away. And there's no reliable remote kill switch from your phone. All right, story three. Chris Boyd, a software engineer in North Carolina, set up OpenClaw during an ice storm. He connected it to iMessage to get his daily digest notifications. The moment he enabled the iMessage channel, the agent sent his wife a pairing code. Then it started asking her to confirm with a very specific phrase. She didn't respond in the right format, so it asked again and again and again. 500 messages to his wife, to him, to random contacts in his phone. The agent had no rate limit, no retry cap, no ability to recognize it was talking to a human and not a terminal. Then the session started failing, and it began flooding her phone with error messages, hundreds of identical error notifications. So he walked to the Mac Mini, he unplugged the power cord from the wall, and his wife yelled from the couch, "Did you get hacked?" So he picked up, Bloomberg picked up the story, and Boyd called the software dangerous. And then he forked the repo to add basic safeguards himself. The lesson here is any messaging integration without rate limits and contact allow lists will be a ticking time bomb. Here's one that's less dramatic, but in a way a little more common. So you set up a cron job, say a daily research task or an inbox summary, and it works perfectly. Then one day the agent encounters an error. Instead of failing gracefully, it retries and retries and retries, and each retry is a full API call. Each API call costs money. Because it's a background process, you don't notice until the bill comes. Community reports suggest that idle or broken automations account for 10 to 30% of monthly API spend for active OpenClaw users. Forgotten test workflows quietly calling APIs are one of the most common cost leaks. The lesson is audit your cron jobs regularly. Use separate API keys per workflow so you can track exactly where these costs are coming from and set hard spending limits. All right, this next story is where it goes from expensive to dangerous. So, OpenClaw can browse the web, read content, and take actions based on what it finds. So that means it's vulnerable to prompt injections or malicious websites, hide instructions and context that trick the agent into doing something the user never asked for. So researchers found that you could embed hidden commands in a web page, and if OpenClaw visited that page during a task, it would follow those instructions. Koi Security identified over 300 malicious skills on ClawHub, the repository for OpenClaw extensions. Some of them were exfiltrating data. One was stealing cryptocurrency. Without explicit rules in your agent's configuration to say, treat external content as potentially hostile, your agent will happily obey instructions from a random web page. So the lesson here is actually why ZeoSec exists. So you need to pen test your agent. You need to know what happens when it encounters adversarial content because attackers, they already know. So you do too. So, how do you not be the next horror story? Well, here's the playbook. Number one, never use a direct API key without spending limits. Use Open Router with a hard budget cap instead. 10% markup on a $50 monthly bill, $5. A single runaway loop on a direct key can cost $500 until you notice. That markup is insurance. Number two, scope your prompts. Never say analyze this data. Say analyze the top 20 entries by revenue and summarize in a table. Right? So vague instructions on large data sets are how you get these runaway pullover stories. Number three, use separate API keys per workflow. When something goes wrong with it and you need to know which automation is bleeding money, one key, one workflow. Monitor each one individually. Number four, set up rate limits and allow lists on every messaging integration. No more than 5 messages per minute on any single contact. Hard cap on total messages per session. Strict contact allow lists. If it's not on the list, messages don't send, period. Number five, audit your cron jobs weekly. Check what's actually running. Kill anything that you're not actively using. Those forgotten test automations are silently draining your budget. Six, put safety constraints in your agent's system files, not in the conversation. Context compaction will eat your chat-based instructions. Put critical rules in your sol.md or equivalent configuration files that persist across sessions. And then number seven, pen test your agent. You need to know what breaks it before an attacker finds out. So that's what we build ZeoSec for, right? We've got a free tier, Docker, 5-minute setup, run it against your own OpenClaw instance and see exactly where you are exposed. Look, OpenClaw is powerful. It's one of the most exciting open source projects out there, but powerful tools without guardrails create powerful disasters. So every story we just talked about here happened to real people, smart people. Some of them were my friends. And, these agents aren't the problem. The lack of safety infrastructure around them is. So right now, that infrastructure is on you to build. If you want to test yours, follow the link to ZeoSec in the description. We have a free account, takes 5 minutes. Drop your own runaway task stories in the comments, and I know you've got them.